Hello everyone, today we are going to go over the blind 75 in C++, and today we are working with reorder list. Now, to be able to give a breakdown of exactly how we need to solve for this problem, first we need to ask ourselves these 4 questions. What are inputs going to be? What data structure / algorithm / technique to use? What to do with the data? And finally, what our output is going to be. So now, just to give a breakdown on the problem, you're given the head of a singly linked list. Well, we already know exactly what our input's going to be. The list can be represented as following. We have this order, and now we need to reorder list in the following form, as indicated over here. Symbols can be confusing, but again, it's going to be agnostic just based on the following formula that we would have. So it's saying you may not modify the values in the list nodes, only nodes themselves can be changed. Okay, so we need to focus on the nodes position. So we need to change the nodes position based on their desired order. And we need to return a modified length list. Alright, so the technique for us to be able to solve the following problem that we would need in order to rearrange the order is that we are going to be using a fast and slow pointer method. It's the tortoise and hare algorithm. Where we have a fast and slow pointer. And we focus on dividing the linked lists based on their halves, reverse one of the halves, then merge them together. So, the steps for us to be able to solve the following problem are as follows. Step 1, we're going to have the edge case where we have a null pointer. Step 2, we're going to initialize 2 pointers at the head of the list to find the middle. In step 3, we're going to move the first pointer 2 steps at a time, and the second pointer 1 step at a time. Then the next part, we're going to reverse the second half of the list. The 5th step, we're going to merge the 2 halves, taking 1 node from each half alternatively. Then we're going to initialize our 2 halves and expand upon the relationship between the first and second nodes. And finally, we're going to set the second node as the next node. So to give the following, what we're going to do in our following steps, I'm just going to move all this up here. So we have step 1, step 2, step 3, step 4, step 5. Is that in step 1, we're going to have the head. If head null pointer or head of next is going to equal the null pointer. We're going to return this. Then for step 2, what we will do is that we're going to initialize the 2 pointers to the head of the list to find the node. So it's going to look like this: list node, slow, head, and then also we'll have the same for fast. Hence the concept of hence the tortoise and hare type of method. And then what we will be doing is that we're going to move the first pointer 2 steps at a time, second pointer at least 1 step at a time. So that will be step 3, while fast and fast move over next. We'll have slow equal to slow next, and then we'll have fast equal fast next of next, because the fast node is intended to be ahead of the slow node. And the fast will be the second half and the slow will be the first half in order of reversal. Then we're going to reverse the second half of the list. So the way we do that is that we're going to have a list node for a previous that will indicate the first part. We're sending it to null. And then what we will do is that we are going to then have the same. Make sure you also capitalize your L's. We're going to set our current to slow, which is called up here. Then we are going to initialize our next node as well. And we do so by the following. And so what we will do is that we are going to have a while loop that's going to represent the current. Then we're going to have a next node redeclared as current for next. Then we'll have the current node next step equal to previous. And the reason being is because we're doing a swap in this case. So we'll have previous equal current, and then our current equal to next node. Then for step 5, we are going to merge the two halves, taking one node from each half alternately. So then we are going to have the list node for first equal to head. Then we're going to have the list node for the second one equal to previous as our. Once we divide it all up, then what we will do, and this is the initialization part, then this will be, we will expand upon the relationship, so we'll have while second is to next. We will then have the next node equal to first to the next. Then we're going to have the first next equal second. Then we'll have the first equal next node as a swap indicated. I'll be the first half, and then we're going to set the second node as the next node, which will be C. So next node equals second, next, second, next equal first. Then we'll have second equal next node while we are looping through accordingly. There we go. It's supposed to be in here. Just making sure every single bracket is counted. Let's take into account. Yep. So let's double check on everything. Misspelled here. Alright, passes all the test cases and submit. Okay, and so for a solution, just to give a breakdown on the time and space complexity for the following, is that the time complexity for our solution is going to be O of n, where n is the number of nodes in the linked list. And this is because we are essentially doing a single pass over the list, finding the middle, reversing the second half, and merging the two halves. Then for the space complexity, it is going to be O of 1, because we only use a constant amount of space to store our pointers. And yeah, so, and we're also not, and we're only using the linked list that we're also given at the same time for a given head, so that also gives the description for the space complexity as well. So yes, this was reorder list. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.